Okay, here's our video today. Properties of matter and changes in form in chemistry. So, what is matter, right? That's the first thing we should talk about. And we know it's only 5% of the universe. The rest is dark energy and dark matter. But for this video, we're just concerned about matter. So, anything that occupies space and has mass, well, that's matter, right? So if you can see it, you can touch it, you can taste it, you can smell it, you can feel it, it's matter, right? From your dog, your cat, your pencil, your Chromebook, your phone, Aunt Sally, your sandwich, whatever it is, it's matter. And of course, there are properties of matter, physical and chemical properties. We'll start with the physical properties. And there's two parts of physical properties we'll talk about. So if you look at an object, whatever the object is, your phone or whatever, how it looks, how it feels, how it acts, those are all physical properties of matter. So let's get a clean page first of all. All right, and let's look at these physical properties. So one physical property, and we should have a pen working first. I'll use red. Is color. It's an easy one. Color. It's a quality of an object, right? It's color. And then, of course, there's size. And there's volume, right? Volume. Volume is the amount of space a substance or an object occupies. It's volume. It's density. And a lot of people misunderstand density. But density is the ratio. Let's write it down. It's the ratio of mass and volume. It's the ratio of mass and volume. So in other words, in simple terms, you can have two things that look like they're the same. Let's say they're the same shape and size. But one could be denser and tip the scales because the atoms inside the object are packed tighter than maybe these atoms over here. So it's denser. What other physical properties? Well, we have the boiling point. We can see the boiling point, and if like we can see water boil, and of course we can put down the melting point. We can see water freeze, right? And then there's solubility. How easily something dissolves in another substance, like salt dissolving in water and so forth. And of course, whether or not something could be magnetic. Right? These are all physical properties. Now there's two types of physical properties. Right? So let's put the types over here. We'll make a box over here. Two types. Intensive, that's a type. Intensive and extensive. Extensive. Those are the two types of physical properties. So intensive does not depend on the amount you have. Let's write it over here. Let's put a little parentheses. Does not depend. I think we're not going to fit it. Does not depend on amount. And we just barely fit it in. So, for example, if we're looking at density, right? Density is intensive. It doesn't matter how much you have of substance of something, right? It's going to have the same density. So intensive, put a line, it goes right to density. It's intensive. And why is it intensive? Because it doesn't depend on how much you have of something. Right? It doesn't you can look at also of color, odor. It doesn't matter how much you have. Right? It's still intensive. It's still going to have the odor. The temperature, the freezing point, the melting point, the boiling point, the density, like I said, the state of matter it's in. It doesn't matter. Water is water no matter how much water you have. And of course there's also malleability and so forth. So intensive does not depend Extensive does depend, right? So the volume will change, right? The volume's going to change. If it's changing, if you add more, if it changes, like the size, the length, the width, the weight, the mass, the volume, well, then that is extensive. So remember those two. Intensive does not depend on the amount you have. Extensive does. All right, so those are the physical properties. Let's look at chemical properties. With chemical properties, if any characteristic for chemical properties is something that can be determined only by changing a substance through a chemical reaction. So some properties, and let's write them over here, they could be reactivity. If we get our pen working, right? And maybe we'll use that color. Reactivity. We could see how sodium is very reactive, right? We can see how potassium is very reactive if we introduce water, right? Because the alkalis are very reactive. So that's a chemical property. If you put sodium or potassium and so forth, all those alkalis in water, they will react violently with water. And there's also toxicity. Flammability, right? These are all things you can observe with chemical reactions. And also, we can put down combustibility. Combustibility. Say that twice. Right? So those are chemical properties. And just to add some more stuff here. So toxicity is, again, how dangerous, how poisonous or damaging a chemical substance may be to other things, to organisms, for example. I think that's self-explanatory. And flammability, whether a substance will burn when exposed to a flame. Combustibility is the measure of how easily a substance will burn in oxygen. So how do you determine the properties of matter? Well, if you can identify the properties of this substance without changing it, is it a chemical or physical property? So if I say we want to identify, let's put a line here. We want to identify whether it's chemical or physical. Is it a chemical or physical property? And we say, can you identify the property of this substance without changing it? Well, without changing it, it would be physical property. In order to identify it with a chemical property, it has to change. So what are these physical and chemical changes? Let's get another clean page. So if we start with physical, we'll say a physical change. Again, let's make sure the pen is working. We'll stick with that color. So we'll put a little arrow here for physical change. Any alteration, right? Any change to the size, right? If it's changing size, well, then we know it's a physical change, or shape and so forth. For example, when ice cubes melt, that's an easy one, right? So here's an ice cube, right? When it starts to melt, here it is melting away, right? So when it starts to melt, well, it's undergoing a change. It's going from solid to liquid. It's still the same substance, right? So the final substance in a physical change has the same matter as before the change. But in a chemical change, put it over here, right? And remember something very important. Matter cannot be created nor destroyed. You should know that. Probably learned that way back in middle school. So a chemical change occurs, again, when matter changes into a new substance. We should know that, right? Matter changes into a new substance. But it's not destroyed. It just undergoes a change. So remember, chemical changes do not alter the molecular makeup of the substance, right? The final substance is not made of the same matter as before the change, but matter is still there. Again, it wasn't destroyed. Let's do an example with let's see if I can make a log. A burning log. Here's a log on the flame. Right, you got to burn this purple wood if you can find that. So when you're burning a log, the change is it goes from a solid piece of wood. It's going to go from what? It's going to go from this weird looking piece of purple wood. Right? It's going to go from wood to ash. Right? It's the same amount of matter. Matter wasn't destroyed, but it just went from a wood to a new substance, which is ash. So we have a chemical change. How do you know when something has undergone a chemical change? Let's look for another example. What about a change in color? Like if you have an apple, right, and there's a change in color, is it a physical or chemical change? What do you think? Well, if you leave a red apple outside for a long time, outside of the refrigerator for a while, eventually it's going to turn brown. There's going to be a change in color. So the apple's changing. It could be a change of odor, right? It give off a smell because it's rotting. Substances could have a formation of gas. When they emit a gas, such as vinegar and baking soda, you put vinegar and baking soda. You've done this probably before, way back, probably even in elementary school, when you've made those volcanoes with vinegar and baking soda. The bubbles show that a gas has formed, a chemical change.